Hey everyone, this is Mike Wolf. Welcome to the podcast. Today's conversation is with Will Patrick, the CEO of Culture Biosciences, a company that makes cloud-connected bioreactors. And what that is and what they do is something that will certainly talk about on the podcast. But this is one that I was actually looking forward to for quite some time because Will just has this really interesting background, comes from a world of hardware, mechanical engineering, worked at Google X, helping them launch their and prototype their drone delivery service, and just working on some really interesting things around hardware engineering and software. And ultimately, he became interested in the world of biomanufacturing and had a time where he studied at MIT Media Lab and got really interested in things like DNA and nanostructures. Ultimately, he realized the world he came from, mechanical engineering and software, had all these tools which allowed people to move quickly, to scale, to build. And he realized that the world of biomanufacturing didn't have that. And so he saw an opportunity. And out of that was born Culture Biosciences. And so we talk about that, his thinking process, and his journey along that way. So it's a really fascinating conversation. I hope you enjoy it. Before we get to it, I just want to mention we will have the transcript of this conversation and the video, if you want to watch it, at Spoon Plus in a couple of days, our premium membership service. So keep an eye out for that. And finally, before we get to the podcast, I just want to mention we are having our third annual Food Tech Live this year, or actually in 2021, in just a couple weeks, January 11th. And instead of going to Las Vegas and renting out a ballroom and paying for cocktails, this year we're actually doing everything virtual. So I'd love to have you join us. It's free. So if you want to catch and check out some of the latest and interesting food tech on January 11th, we'll have cultured meat companies, and we'll have food robots and restaurant tech. So if you want to join us, just go to the Spoon and check out the events tab and look for Food Tech Live and just register for a free ticket. All right, that's it for now. Let's get to the conversation. Well, hey, I'm excited to have Will Patrick, the CEO of Culture Biosciences, on the podcast. How you doing, Will?
I'm doing super well. How about yourself?
I'm doing well, and I'm excited to talk to you. I first heard of you guys when I was talking with Dave Freiberg of the production board and just kind of looking at some of his investments. And this idea of your company just fascinated me, bioreactors connected to the cloud, et cetera. And I want you to go into that. But first, I want you to maybe give us a little bit of background, because you come from more of like a mechanical and software engineering background. And yet here you are, the CEO of a bioreactor service company. How did you make that pathway? What was that roundabout way in which you got into there?
Sure. I mean, it's really all about, for me, like a love of manufacturing. So I've always loved how things are made, how things are created, and since being a kid, and I've always loved to build things, like doing fabrication, and so I've been really fascinated with different manufacturing systems, whether it's injection molding or new materials or whatever, like computer numerically controlled CNC equipment. And so when I started getting into biology, it was really from that lens. The first thing that I got really interested in was actually like DNA nanostructures, which is how you can program DNA to assemble into these really small nanostructures. And it's really cool academic work on that. And I found that just to be so fascinating as sort of like the smallest form of, precise manufacturing we can do as people. And that was sort of my gateway into, wow, biology is sort of, it is a manufacturing technology, and we have the ability now to design it and using DNA sequencing and synthesis. And I got really interested in that. And so that was, 8 or 9 years ago now, that eventually led me to do this like sort of interdisciplinary degree at the Media Lab, where I was sort of studying biologically based fabrication. Right. They're using biology as a part of the fabrication process, or being inspired by biology, or using bio-based materials. Those sort of all those different topics were the things that we were researching there.
And you did, before you went there, you were at Google's X factory, their Moonshot factory, working on a number of projects like their drone delivery service and their virtual reality glass. So you kind of had that hardcore hardware engineering future look, but then before you went, so you had that interest in biology before you even went back to MIT.
Yeah, it was actually at Google. Like one of my colleagues, who remains one of my best friends, he just was someone who had been studying protein folding as an academic. And so he had been studying how to do the protein, sort of solve the protein folding problem, which, there's been some really recent work by
Google's AI actually.
That has done very well on that. But so anyway, back in the day, he was a researcher on that topic, and so he was sort of he was just one of my colleagues, and so he sort of sent me some papers and sort of piqued my interest in the topic. And so at the time I was working on, I don't even remember if I was working on glass or if I was working on what became Project Wing. But I was working on something very non-biological at the time.
And what's interesting to me is, having that, mechanical and kind of computer software engineering background and this fixation with the bio and synthetic biology. It does seem like bringing the skill set that you have to biology is a really interesting potential hybrid, right? And I think it's like a skill set we're seeing more and more brought into this space. And so I think there's peers to you in the space that are also starting companies.
Yeah. So the way I would think about it is, so when I was finishing up grad school, and I remember talking to an advisor, and I was like, I feel like I'm really excited to, maybe make a new biomaterial or design something with biology or et cetera. But I felt at the time that the tool set, the toolkit used in the industry was just like not where it needed to be to like have all of these new bio-based products get out there. So, basically where I saw my role to be is like, as someone who's a mechanical engineer or hardware engineer, I could create better tools. I could create these better systems, these infrastructure that can be used in order to get more exciting, interesting products to market. And so I think someone from my background and also my co-founder's background and others like us, we think about like, the infrastructure for doing the work, the value chain that sort of, supplies the biomanufacturing companies, these companies producing a new protein or a new whatever. We don't take that as like, is unchangeable, right? We think we can innovate there. We can change the hardware. We can change the software. We can build new things that just make it faster or easier or cheaper or whatever in order to get these products to market, right? And so really, I think, my role is really bringing that engineering lens to understand like, what are the rate limiting steps from products getting from discovery to being in people's, stomachs or whatever the end application is. But like, what are the rate limiting steps in the entire process, the entire value chain from discovery to manufacturing? And, try and find those and then try and create new solutions for them. And so that's really what I'm excited about. And I think folks with that sort of mechanical or software engineering background are also maybe are thinking in that way as well.
Right. Because the software industry had like decades and decades where it used to be a lot harder, I imagine, to create like a fully operational program, but eventually all these tool sets were created and then just accelerated it. Yeah. And I don't know if you want to call it agile bio development or whatever the term would be, but like, it does seem like you're creating these tools for these.
That's right. Yeah, so I think that's a great, sorry to cut you off, I think that's a really great point, and it's very much like the inspiration for me and Matt. So, as a software engineer, obviously Matt or any other software engineer might use one of the myriad cloud, technologies today, whether it's Google Cloud Platform or AWS or what have you, and then all the different sets of tools that are built on top of those infrastructures. In the manufacturing world, for me, I use things like, quick like proto labs for CNC manufacturing, or all the different 3D printing service providers, or even someone like McMaster, which can supply parts to me really quickly for prototyping. There's just all of these sets of tools that make it really easy for me to design a new hardware product and get it manufactured pretty quickly. So we definitely we're coming into this field as like, there's none of that type of stuff for biomanufacturing. That makes it easy, cheap, fast, quick to develop these fermentation-based products. So, like, let's build those things because we think we've seen the incredible benefit and impact they can have to software or electronics or mechanical prototyping.
And I've seen you guys described as maybe it was on Dave Freiberg's production board website, is kind of AWS for bioreactors. And you mentioned AWS yourself. And for those of you listening who don't know, it was this infrastructure cloud platform that Amazon essentially made available for people building cloud services that really, I think, helped kind of set off a wave of innovation and a lot of new web services. And so you're building this foundational platform with your bioreactor service to help kind of spur a wave of innovation. So can you talk a little bit about what you're building with Culture and what the bioreactor cloud service is?
Yeah, I think that's a good analogy. Another analogy I'd like to make is to the semiconductor industry, when there's been a big transition in the last 30 years or so to these fabs like TSMC, and then you have these fabless product companies that use them in order to do their semiconductor manufacturing. So it's another inspiration I would say we have in terms of another industry that has sort of their manufacturing has really shifted from being very vertically integrated to one that is where you have a provider like a TSMC that can do that scale up manufacturing. Yeah, so Culture is really focused on doing something like that for the fermentation space. So the first thing that we're working on, or we have built, is what we call like a cloud bioreactor facility, and it's in South San Francisco. It's got about 100 small scale bioreactors, which can be basically rented out as a service, as a subscription service by biotech companies. And so it's, instead of having to build out an entire laboratory of these small bioreactors and hire the staff required and do all the data management work and the data analysis work, we do all of that. So our client would basically be renting out the bioreactor operations they need in order to do their R&D development work. And for those who don't know, the reason why that matters is, let's say, a typical customer of ours might be making a food protein. So they might be trying to, genetically modify a bacteria or a yeast to produce a new food protein, right? And their big goal for that type of company is their big challenge, I should say, is to produce a lot of that food protein, like basically produce it really efficiently, have a really high yield, because that means when they produce at scale, they can produce it cheaper. And so they have to do tons and tons of optimization in order to get to a high yield. You can think about it as sort of like changing up the recipe or the brewing process. If you were, making optimizing your chocolate chip cookie recipe or optimizing the kombucha brewing protocol. And it's sort of a similar concept here, where you are literally doing all this optimization of the growth the growth recipe for these organisms in order to have higher yields. Companies are also doing a lot of different genetic engineering of their organisms themselves, and they have lots of different versions of those organisms, and you need to test them to see which ones are the better performers. So all of that needs to happen, all these things, the optimization of the recipe, the optimization of these different strains, they need to happen in these small scale bioreactors, which is what we have. So these companies are optimizing their growth processes in our infrastructure in order to have a high yield process so that they can actually scale it up and produce their product in an efficient manner.
Yeah, and otherwise they would have to go out, take some of their venture capital and invest and buy their own bioreactors, build like data analytics and software around it to manage it. But you guys are essentially providing that as a service so they don't have to expend their capital or their time that way, and it helps them get to market faster. You have companies, I think, like Geltor, I believe is one of your customers, and you probably have a number of different alt protein startups working on your bioreactor services.
Yeah, we have over 15, 20 companies at this point who use this on an ongoing basis. And one thing that's super fun for us is they really range in terms of what they're producing. So we have companies producing these food proteins, like a Geltor would be a good example of that, or Claire Foods, for example. But then we have pharmaceutical companies we work with, so who are making sort of new therapeutics. And then we work with a bunch of bio-ag companies, which is really cool. So these companies working on, maybe a biopesticide or a biofertilizer, where the organism itself is the pesticide or the fertilizer. So there's just lots of fascinating different applications that are all need this.
So when we think about a company like a Clara Foods or Geltor coming in there and they want to optimize their proteins, what stage are they in, right? So it's they're doing optimization. They're basically looking to build their products so they can scale it, but they're not in the phase where they're manufacturing at high scale. It's more still in the product development phase, right?
It's interesting. It's at many different phases. So, there's needs, and the needs change a little bit depending on the stage of the product. So the early stages, there is a lot of early stage discovery work, sort of what would be called like process development, just figuring out what is the high level recipe that we want to run. There's also a lot of work doing that strain optimization that I was telling you about, where you would be running tens or hundreds or thousands of different organisms and seeing which ones are the better performers. But what's interesting is even when you're scaled up and you're doing commercial manufacturing, there's still actually a lot of need for doing this work. One is you might want to further improve your economics, because if you actually are commercially operating, then you have a huge incentive to maybe decrease your cost by 5% or 10%. So we end up having a fair bit of work where it's still a commercial process, but you're still doing a lot more optimization. And then this is getting a little bit into the weeds, but often you want to even understand your process for a commercial process. So for example, when you're actually doing commercial manufacturing of one of these products, one thing that's actually really important is what happens when there are small problems in the manufacturing at large scale. So what happens if you accidentally made a mistake and you did something else that you weren't supposed to do, or you instead of having the temperature at one set point, it was at a lower temperature. So it can be really useful to understand, have a bunch of data to know what's going to happen in that case, because one batch might cost you $100,000 to be running, and so it's good to know oh no, it's fine, we should continue running that process because we have data to support that our process is fairly robust there, or we should stop the process. So there's actually even reasons to be collecting data for that type of robustness testing for a commercial process, even past the optimization of the yield.
So typical.
Let's put it this way: our customers, maybe counterintuitively, we have many customers who are not just the early stage startups. We actually have the bulk of our business is with either faster growing sort of mid-sized companies or even larger companies. So there's a lot of need for this work, even for those groups. And
you guys make a point of it being your bioreactors are connected to the cloud and you have these data analytics. So talk about how someone's generally working with you guys. Are they oftentimes having a scientist in the lab and then they maybe go back to their lab and kind of observe the analytics, or how's the general working relationship and how does it kind of play out?
Generally speaking, on a week-to-week basis, we're talking to the client and they're letting us know sort of what they want to run. And then we're executing it and they're seeing all the data in real time. So all this data is streaming back on these charts and they're viewing it and looking at it. We also have cameras actually on every bioreactor, so they can even look at images of the bioreactor themselves and check them out. Then at the end of an experiment, we will send back samples to clients if they would like them. So sometimes our customer might want to do some additional analytics of their product. And so we'll send back all these samples so they can do that if they'd like. When we start working with a customer, there's like an onboarding process where it's called technology transfer in the industry, but basically where we understand exactly what they want to run. And then we make sure that the work they're doing at Culture is of high quality and it's meeting the standards that they would expect. But yeah, on a week-to-week basis, they tell us what they let us know what they want to run, and then they basically sit back and check out the data as it comes back to them. So going back to kind of the idea and how you got it, and you and Matt kind of co-founded it together, Matt Ball. How did we talked a little bit about you saw a need in the market, but was there an aha moment where you said, hey, I want to start a bioreactor as a service company? What's that early origin story? Yeah, sure. So I built a bioreactor actually as an art project over it was in 2015. It was a photobioreactor, and it was my first time like building a bioreactor. And I was just sort of interested, and I was researching about them, and I had like an offhanded idea. I was like, I wonder if there's like a AWS for bioreactors or something, like, where you can just go use a bioreactor, and like that could be interesting as an idea. But then like about 6 months later, I was actually really starting to investigate real ideas, and I'd still thought of that one. I was like, maybe that's worth looking at.
And were you using the 3D print? So there were like 3D printing services like that, right? So was that one of maybe the inspirations? Because you were doing a lot of kind of 3D printing services manufacturing.
Totally. I mean, basically the major concept was like, I was aware that like, okay, a lot of these companies have these bioreactors. Like maybe it'd be better to have like a outsourced provider that's more automated. And like, that was like sort of a quick idea that sort of was like, in my mind, like a little bit obvious to like investigate. But I didn't really investigate it at that moment because I wasn't even really like seriously thinking about business ideas. But
real quick, before you get going, you made your bioreactor. Was it at your home? Was that like at work?
Yeah, it's a good question. So I just finished up at the Media Lab, and I did this really amazing program that no longer exists, unfortunately, at Autodesk, which is they used to have this artist in residence program where you could basically Autodesk has this amazing facility in San Francisco called Pier 9, which is basically a little playground for people who like manufacturing and fabrication. They have all these fancy tools. And so they basically used to do a program where you could apply, and if you got accepted, you could go there and use all their tools for some, like whatever projects you wanted to work on. So I was very fortunate, and I was, got in, and I did that after my grad school. And it was just sort of this, 3 or 4 month long, like creative period to sort of use the tools for whatever. And so I was, I built this bioreactor at Pier 9 at Autodesk as a part of that project. And it was a photobioreactor. And so that was I did have access to these like sort of fancy CNC tools and 3D printers and things like that in order to build that prototype. So so that was 2015 fall. And then, there was a moment though when the cloud bioreactor idea, like actually was like, oh yeah, this is an interesting idea. We should really start pursuing it. So that was in the summer of 2016. And we basically, Matt and I's approach to starting the company was one of just like truly going and like talking to people and like trying to understand, because we knew we were we were really excited about fermentation and synthetic biology in this field, and we wanted to contribute, and we knew we wanted to build tools, like that's our background. But that was how open-ended it was, truly. And so we just went in with like a really open mind and talked to people about like what their problems were. And so we just fortunately had a lot of great conversations. People were really open, and we went on all these tours of people's labs. And one tour of, we were talking to someone at one of the big industrial biotech companies in the Bay Area, and we were going on a tour of their lab, and they have hundreds of bioreactors, and they were like, we would run 10 to 100 times more of these if we could. Like the data is so good coming off of them; it's always a bottleneck. We would want to run way more if we could. And that was the first moment I was like, oh wow, this is a really interesting area to look at. Like this is one of the top companies in the field with one of their leaders in R&D telling me that this is their key bottleneck. They would want to run way more of these things. So that's really interesting. Like we should look at that. Like, can we make them more automated? Can we do this in a different way? So that was where I started my like little, entrepreneurial spidey sense got more tingling, I would say. And then I think, there's a couple of startups that were very, they were very kind and allowed me and Matt to come and like hang out with them for about a week. So we spent 1 week at Geltor, when Geltor was like 6 people. And they just moved into their facility in San Leandro after their IndieBio time. And so we spent a week with them, which was super fun. And like just hanging out with their folks in the fermentation lab. And then we also spent a week at what was then called Move Free, which is now Perfect Day.
Wow.
And similar stage, they had been at maybe 5-6 people. They were in their South San Francisco office. So yeah, just like
Those
learning.
are early days in the precision fermentation world. I feel like when they write the book and like, you guys gonna get, that's like the homebrew, like computing club of like
Yeah, I
precision
mean,
fermentation.
yeah, I mean, we were just sort of, again, like, very kind for the folks at those companies, and they're still good friends, right? To just sort of bring us in and allow us to be there. And we learned so much. I mean, that's where we really started understanding, okay, this is what these companies are currently doing. Here's the technology they're using. Here are their challenges, like really just witnessing it all, and understanding, getting a little bit more of an in-depth understanding of like, okay, here's where people are spending all of their time. Like, here's what the challenge, here's where the really painful parts of the process are. And that was like the sort of really, really like in-depth understanding that Matt and I needed to start building in order to actually build bioreactors and services. Cause it's pretty freaking complicated running these bioreactors. Actually, it's not a simple thing. And it was really important for me and Matt to sort of start really understanding the complexities. And that's when we started doing it, was that in that summer. And when we started crystallizing sort of the core concepts and ideas behind the company.
It makes me wonder, I mean, like we see my kid's pretty involved in STEM robotics. He was in high school. And I've been really impressed with how much a lot of these education systems have incorporated additive manufacturing and even CNC type machines in their STEM programs. I'm wondering if, based on what you're thinking is looking forward, well, can we see like maybe 5-10 years from now, some of these programs having bioreactors as maybe like a core built, something that's in the lab that just students go and play with?
Yeah, I totally think so. I think we're actually already seeing some really interesting stuff there in biotech. And, iGEM is really leading the way, where iGEM now is in high schools, and there's just, it's such an amazing influence and sort of organization. Maybe I guess you could compare it to like First Robotics, right?
That's what I'm talking about. First is like,
so iGEM is really just incredible. I think for bioreactors, right, haven't been a part of iGEM. Usually when you're doing your synthetic biology iGEM project, you don't usually bring it into a fermenter. Usually you're staying in, you might be in a flask, or you might, have data from plates or whatever. So I definitely, I'm hopeful that culture can play a role there at some point in the future, where we could sort of either, offer up some services to iGEMers or other folks. Then there's some other like cool, like kit type of work that people are doing to make new sort of even, lower cost sort of synthetic biology kits. And I would love to at some point like make the educational version of our culture reactor. That would be super neat. So people could just, brew things and check it out and learn a lot about fermentation.
There's a company out of Taiwan that's looking to make a home fermentation, basically not necessarily bioreactor, but just like for fermentation for kitchens, et cetera. So I thought that was kind of interesting. But in 2016, those are pretty early days. I mean, you did have IndieBio, but I'm wondering, like, was that going around a Silicon Valley and trying to tell the story of what culture could be? I think nowadays it's just obvious, right? We've had massive funding rounds for some of these synthetic biology companies, but back then it was a lot earlier. I mean, you had, like you said, Geltor and the precursor to Perfect Day. What was those initial pitch meetings? If you had them, were people scratching their head, or did a lot of them get it?
I think a lot of them did get it, because it's still in 2016. You had Ginkgo and you had Zymergen. You had a few companies that were really starting to get going. And so you did have I think Silicon Valley, the investors did get it. One thing that wasn't as strong in our like story of the company, then, like, we really were focused in our initial 6 months, year on synthetic biology. And that's where we were thinking. But, right now, a good chunk of our work is in biopharma, right? And so, that's something that we frankly, I feel like it's almost embarrassing to admit, but like truly early on, we sort of missed that, which was that, we would be serving both industries. And for this service, right, is really important for both. And it's got a lot of people who need this, who are just working on new therapeutics as well as new foods. But yeah, to answer your question specifically, because of some of the success of those companies, and even companies like Bolt Threads, for example, there was quite a familiarity in the sort of investor community.
And so, looking at the space, you're pretty analytical and saw a need. You're as you said, your spidey tingly sense started to kind of go off, and you build culture. But as we build out this industry more, and you see these companies trying to build, the next impossible, but in fermentation based products, or even like eventually cultured food, what do you see other opportunities in building underlying infrastructure? Maybe it's maybe something you guys want to go into. You don't have to tip your hand too much, but it seems like this area can use more infrastructure to help these companies scale over time.
Yeah. So the obvious one is larger scale, where there's big bottlenecks for doing anything really larger scale. So pilot scale, there's big bottlenecks. Commercial scale, there's big bottlenecks. So that remains to be the biggest challenge in the industry, is like, how do you quickly scale up? Who do you scale up into? The risk of scaling up, the time it takes to find your CMO, that remains, in my view, the biggest problem right now. And it's both the fermenters, but it's even more so the purification step. So like, you have this, hundreds of, maybe, 100,000 liter fermenter, and you have this massive amount of liquid broth. Then you have to purify out your one protein, right? So that's a huge challenge. That's the area in my mind. That's the biggest area for innovation that's needed, is the larger scale. So that's definitely an area we're interested in. We're trying to figure out how we can help there, either by just supporting our customers as they scale from our small scale fermenters into those larger scale sites, or doing some of our own innovations. That's very much an active area of interest of mine that I'm looking into. I think there's a lot of other potential areas. So one is like, if I'm looking at on the organism design side, I do think there's an opportunity at some point for someone to offer more of a service around just like a pure fee for service around organism design. Just like, where you're just really offering up all of the liquid handling, the DNA assembly work, the screening technologies. I find that a lot of our customers are just building out very similar, sort of almost carbon copies of the same sort of set of infrastructure to do organism, like their own like little bioworks to do organism construction and design. That design build test cycle for new organisms. So I do think that's an area where you could have a more pure, fee for service business that is just sort of offering that up as almost like a cloud service. It could be sort of, I could see a fit there. I don't know what the economics are like, and there's probably some reason why people haven't sort of taken that approach. But that could be another one that I could see as well.
So on the entire kind of production value chain, from kind of like concept to scale, you see opportunities both kind of before people get to culture biosciences and ultimately afterwards. But it sounds like there's lots of opportunities here for people to continue to innovate and build the tools to kind of make this whole business scale further.
I totally think so. I think, my vision for this industry, my hope, it's my vision, but also my hope, right? Is that you have the future looks more like this sort of semiconductor business, where you have a number of these innovative product companies that are, quote unquote, like fabless, that, are discovering new, they would be discovering new products. They'd be, really understanding the science of how do they make this product, but they don't have to worry as much about all the infrastructure required to do the science or to do the scale up. And they could instead, be, really just, focused on discovering good products and then eventually selling good products. But, a lot of the infrastructural elements that are required for all that can be sort of done by companies like Culture that are really, investing in heavily in building great tools that are best in class, and that, all of the different product companies can be using to, get their products to market. So I think that's where the industry will go. I think it makes sense logically, but it's also I think it would also lead to an industry where you have this a number of product companies, right? That are, and it gets easier to make becomes much easier to start a new company and making a new protein, right? And I think that would be a really healthy ecosystem to have for cellular agriculture and synthetic biology more broadly.
Yep. Well, it'll be exciting to see how this infrastructure industry for synthetic biology and cellular agriculture builds out. And Will, Patrick, sounds like you guys are an important part of this space now. So I appreciate you spending time with me today.
Thank you so much. I really appreciate it, Michael. And happy holidays.
Happy holidays.